Scene in the Gryffindor common room. Hermione, I must tell you something.
What is it, my love? Last week, I got really drunk with Harry on butterbeer and I slept with someone. What? How could you? That's not even the worst part. I have to get tested for HIV. Will you please come with me? Oh, okay.
Human immunodeficiency virus, HIV, is an enveloped retrovirus. The retrovirus infects CD4 positive cells by inserting its viral RNA into the host cell. This is backwards of the normal central dogma. There are two types of HIV, 1 and 2. The test methods discussed will be testing for HIV-1. HIV-2 is a minor isolate found mostly in West Africa, causing latent, less pathogenic infections. HIV-1 accounts for 95% of infections.
Let's go through the HIV replication cycle. First is the fusion of HIV to the host cell surface with its CD4. Second, HIV RNA reverse transcriptase, integrase, and other viral proteins enter the host cell. Third, viral DNA is formed by reverse transcription. Fourth, viral DNA is transported across the nucleus and integrates into the host DNA. Fifth, new viral RNA is used as a genomic RNA and to make viral proteins. And sixth, new viral RNA and proteins move to the cell surface and a new immature HIV forms. And finally, seventh, the virus is released. Viral protease cleaves new polyproteins to create mature infectious virus.
Ron and Hermione enter Hogwarts medical office.
Neville, what are you doing here?
I majored in herbology, but minored in Muggle lab sciences. Sometimes Muggles' analyzers are better than magic. Whooping gargoyles, Ron. You don't look well. Did Hermione cast a spell on you?
No, Neville, I need some classified testing. Promise you won't tell anyone?
I am bound by Muggle HIPAA. What's going on?
Ron needs HIV testing because he cheated on me.
Awkward. Well, let's get started.
We will first need some blood.
Boggers, I'm not good with pain.
The medical merge of Muggledom and wizardry allows us to mix Muggle and magical procedures. In the Muggle world, testing would take 1 to 2 days. However, in our world, it takes a matter of seconds.
First, we will run a 4th generation ELISA test for HIV. Accio ELISA!
Let's take a closer look at HIV screening. Using the 4th generation ELISA HIV test, this test is an immunoassay that detects HIV-1 and HIV-2 P24 antigen. It also detects IgG and IgM antibodies. The confirmatory test for HIV is carried out only if 2 out of 3 of these ELISA tests are positive. As you should well already know how ELISA works, the plate well is coated with an antibody, and in this case, the antigen exposed to the patient with potential antibodies or antigens. The assay buffer is added, an indicator links to the antigen, and an antibody complex. The substrate is added and initiates the color change for a positive signal. Ron's P24 HIV antigen has linked to our reagent antibody antigen complex, and we're seeing the color change as positive.
Ron, your 4th generation ELISA HIV screen test is positive. This generation can detect the P24 antigen, which allows early detection. It can take up to 6 months to develop antibodies, so a false negative would have been possible with an earlier generation testing during that window. We have to repeat this test 2 more times before we send your sample for confirmation testing. Well, Ron, looks like the test came back positive.
Oh no! What am I going to do?
Hang on a second. There is one confirmatory test we can do. Next, we must conduct a nucleic acid test called HIV-1 RNA qualitative assay. It involves 3 main steps. First is sample preparation.
During sample preparation, RNA is isolated from the specimens via the use of a target capture. Specimens are treated with a detergent to solubilize the viral envelope, denature proteins, and release viral genomic RNA.
Number 2, HIV RNA target amplification.
Target amplification occurs via TMA, which is a transcription-based nucleic acid amplification method that utilizes 2 enzymes. You can read them. The reverse transcriptase is used to generate the DNA copy of the target RNA sequence, and the other thing amplifies the DNA copy template.
In step 3, there's detection of amplification products.
Detection is achieved using the HPA single-stranded nucleic acid probes with the chemiluminescent labels that are complementary to the amplicon. The labeled probes hybridize specific amplicons. The selection detergent differentiates between hybridized and unhybridized probes.
Well, looks like you are qualitatively reactive for HIV. Uh-oh, we must check on your viral load next. What's viral load? Well, Ron, after a confirmed diagnosis of HIV, the status of the infection and antiretroviral treatment can be monitored through viral load testing. RT-PCR, or qPCR, is an assay that can determine the quantity of the virus, aka viral load. Viral load is used for disease prognosis and treatment monitoring. HIV patients with high viral loads above 100,000 copies per milliliter, are at risk to progress to acquired immunodeficiency syndrome or AIDS. Am I going to get AIDS? Not necessarily, Ron. The goal of antiretroviral treatment is to help the patient maintain a low viral level, thus decreasing the patient's risk of AIDS. Antiretroviral therapy can significantly reduce viral loads in as soon as 1 week. So how can I know my viral load? Different molecular-based methods may be used to quantitate or determine the viral load depending on the target intended to be amplified and sensitivity desired. Different methods may be also used to produce different results, so the same test should be used every time when monitoring a patient.
The purpose of HIV-1 viral load assay is to generate amplified product from the RNA genome in clinical specimens. Doing so will determine the initial concentration of the RNA, aka the viral load, prior to amplification. First, in sample prep, target RNA molecules are extracted and concentrated with magnetic beads. Interfering substances are removed by washes. The reagents are then added and consist of HIV-1 oligonucleotide reagent/probes, thermostable reverse transcriptase POL, activation reagent, HIV-1 and internal control primers, and the test sample, aka the patient sample, or Ron's sample in this case. The final elution proceeds to amplification. During the amplification reaction, target RNA is converted to cDNA via reverse transcriptase activity of RT polymerase. During detection, hybrid probes are bound to complementary targets downstream of the primers. In this figure, we used TACMIN as an example. Due to exonuclease activity of the DNA polymerase, the fluorophore is cleaved and dissociated, resulting in fluorescence in the presence of the HIV-1 target. During quantitation, a calibration curve is required to quantitate the HIV-1 RNA concentration of specimen and controls, which is determined through 2 calibrators that are run in replicates. Linearity is established by low, mid, and high control specimens.
Well, Ron, although your viral load is fairly high since you just contracted HIV, none of this even matters since we're wizards. We can just cast a spell and it'll go away.
What? Then why did you put me through all this stress? Well, I order vulnera senator HIV.